Hey guys, so I'm going to try something a little bit different. Going over this study guide, instead of me videoing myself, I'm just going to video my touchscreen here and work on the study guide while you view me working it here. So hopefully this will help you see things a little bit clearer instead of me having to use the whiteboard all the time. All right, let's go through it. I have decided that your test is going to be all calculator based, so you will be able to use calculator for questions 1 and 2 here. For number 1, if you're going to change this from degrees to minutes and seconds, in your calculator, remember that you're just going to hit second angle. And then under number 4, it's going to say DMS. Okay, so if you type that in your calculator and then you follow these key presses here, changing it to degrees, minutes, and seconds, you should get about negative 57 degrees, 19 minutes, and 37.2 minutes. Okay, for number 2, going in the opposite direction, if I give you degrees, minutes, and seconds and ask you to go to the 2 degrees rounded to nearest thousandth, in your calculator, you're going to use the second angle feature to literally type in this number, and that's going to help you with the degree, and that's going to help you with the minute. And then you're going to use alpha plus in order for you to type in the seconds. And so your screen should look exactly like the problem looks. And then you just hit enter, and it's going to tell you that it's approximately 32.469 degrees. Okay. Number 3, give the angle measure represented by each rotation. So for 3 part A, the first thing to remember is that a clockwise rotation is negative. Okay, so if it's a negative rotation, then we're going to do 1.5 times negative 360 degrees. And you should end up with negative 540 degrees when you do that. For 3 part B, let me fix that degree. There we go. For 2.6 rotations counterclockwise, remember that's our default direction. So that's just going to be times a regular positive 360 degrees. And for that, you should get 936 degrees after a 2.6 rotations. For number 4, it says identify all angles coterminal with each angle, and then find one positive and one negative. When it says all, you have to remember that the word coterminal means, or there's an infinite amount of coterminal angles, because it's wherever an angle ends up, we could continue spinning around the circle over and over and over and over and over again in both directions and come up with more coterminal angles. So when I ask you for the representation of all, that's simply taking that angle that I'm telling you, which is 43 degrees, and adding to it 360 K degrees. That K stands for any integer, so that takes care of the positive and the negative numbers for you to be adding 360 or subtracting 360 over and over and over again. And then if I ask you for one positive and one negative, again, there are an infinite amount of possibilities. The easiest thing to do is just to take 43 and add 360 degrees, which when you do that, you're going to get 403 degrees. So there's your positive. And then if you take 43 and you subtract 360, you're going to end up with negative 317 degrees. For part B, we're going to do the exact same thing. The representative of all angles is going to be negative 30 degrees plus 360 K degrees. And then for one positive and one negative, you can simply take negative 30 plus 360, and you will get a positive 330 degrees. And then negative 30 minus 360, and you'll get negative 30 minus 360, and then you'll get a negative 390 degrees. Again, these are only example or optional answers. There are an infinite amount of other answers that you could choose to put there if you'd like. Okay, number 5. If each angle is in standard position, determine a coterminal angle between 0 and 360 and state the quadrant in which the terminal side lies. So this is kind of like number 4, except I don't want any coterminal angle. I want the coterminal angle between 0 and 360 degrees. Okay, so like 472, I realize it's a little bit greater than 360. So if I just go ahead and take 472 minus 360, and then I end up with 112 degrees. 112 degrees, double check, is between 0 and 360, so I'm good to go. And that is going to be in quadrant 2. So you can write your answer like this as a pair. First the degree with a semicolon, and then the quadrants. For negative 995, this is pretty far away from 0 to 360, so you're going to have to do a little bit more work. Oh, no, don't do that. So if we take negative 995 and we add to it 360 degrees over and over and over again. Now you could add it a bunch of different times until you figure out what you need. Ultimately, it's going to end up being 3 times until you get to a positive 85 degrees, which is between 0 and 360, also in quadrant 1. For number 6, I want you to write on the coordinate plane how to find the reference angle in each quadrant. Okay, so if I have an angle alpha, remember quadrant 1 is our friend. If an angle is there, then it is its own reference angle. So the answer there is just alpha. In quadrant 2, to find the reference angle, you're going to take 180 minus alpha. In quadrant 3, it's going to be alpha minus 180. And in quadrant 4, it's going to be 360 minus alpha. So you need to have a solid understanding of that to be able to do the next type of questions, which is to actually find the measure of a reference angle for a particular given angle. So 227 degrees, first need to figure out, okay, well that lies in the 3rd quadrant. So if that lies in the 3rd quadrant, then I'm going to follow the alpha minus 180 rule. So I'm going to take 227, subtract from it 180, and I'm going to get 47 degrees. Remember, your angle, your reference angle, should be between 0 and 90 degrees. For 7 part B, 640. Now, 640 as it is does not lie between 0 and 360. So what I would do first is I would first find the coterminal angle. Find coterminal angle between 0 and 360 degrees first. Okay, so if I do that, that means I'm just going to take 640, I'm going to subtract 360. And that's going to get me, sorry, I'm losing my thoughts here. 280 degrees. Okay, 280 degrees is in quadrant 4. So if I follow the rules for quadrant 4 reference angles, I'm going to take 360 minus 280 degrees, which is going to give us 80 degrees. For 7 part C, I've got negative 1,688. Same thing, I would go ahead and find that coterminal angle between 0 and 360 degrees first. So I'm going to take negative 1688, and I'm going to keep adding 360 to it as many times as I need to until I find its coterminal angle between 0 and 360. Ultimately, if you do that a bunch of times in your calculator, you're going to end up having to do that 5 times. And then if you do that, you should get 112. 112 degrees isn't quadrant 2. So then if I apply the rule for quadrant 2 reference angles and do 180 minus 112, I end up with 68 degrees as the reference angle there. For number 8, it says, if the tangent of theta is 5, find the cotangent of theta. Now, you can think about this in a few different approaches. If I say, okay, the tangent of theta is 5, and I know tangent is opposite over adjacent. Well, if opposite over adjacent has to equal 5, the only way that that's possible in the most simplified form is if opposite is 5 and adjacent is 1, because then 5 over 1 will simplify to get us 5. The next thing to remember is that cotangent is the reciprocal of tangent. So if I just reciprocate, and you could have done this from the get-go, if I just reciprocate 5 or 5 over 1, then the cotangent of theta is simply 1/5. Similarly for number 9, if the sine of theta is 3/8, and I ask you to find the cosecant, if you remember that sine and cosecant go together and they are reciprocals of one another, then there's no work to be done here. Simply the cosecant of theta is going to be 8/3. 8/3. Okay, number 10, find the values of the 6 trigonometric ratios. Oh, lovely. Typo, that should say ratios, obviously, for angle S. So I need sine, cosine, and tangent for angle S. The first thing we have to realize is that we're missing the hypotenuse. So we need to go ahead and use Pythagorean theorem to solve for the hypotenuse. So if we do 21 squared plus 7 squared equals, we'll call the hypotenuse c squared. And then we end up with 490 equals c squared. So that c is equal to the square root of 490. Now, before you move on and just use that number, I hope the number 49 pops out at you. 49 is a square number, and it's clearly a factor of 490. So if I break this up into the square root of 49 times the square root of 10, then I can further reduce this radical to say that the square root of 49 is 7 square roots of 10. So then let me go ahead and label my hypotenuse 7 square roots of 10. Now I have the information that I need to find the 6 trig ratios for angle S. So we're going to do the sine of S first. Sine is opposite over hypotenuse. So this is our reference angle, the angle S. You can put theta there if you want. Opposite of angle S is 21. Hypotenuse is 7 square roots of 10. Excuse me. Okay, 2 things. 21 over 7 can reduce to 3. And then we've got 3 over the square root of 10. Now, we cannot have a radical in the denominator, so we need to go ahead and rationalize this by multiplying by the square root of 10 over the square root of 10. And then when we multiply straight across, we get 3 square roots of 10 over 10. So that's the sine of S. The cosine of angle S is going to be adjacent over hypotenuse. So adjacent to S is 7. Hypotenuse is 7 square roots of 10. And similarly, like this one, 7 over 7 cancels. So we just have 1 in the numerator and then square root of 10 in the denominator, which is still not okay because we have a radical down there and that's not allowed. So then we're going to rationalize that and you end up with the square root of 10 over 10. Lastly, for the first 3 basic functions, the tangent of S is opposite over adjacent. So it's going to be 21 over 7, which is 3. So those are the first 3. If you can get the first 3, the second 3 are pretty easy as long as you remember that sine